Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're continuing with systems, guys, and so far we've learned how to solve systems of linear equations with two variables missing. Okay, there we know how to solve it by graphing, by substitution, by elimination. We know how to set up word problems using this very powerful way to solve word problems. And today we're going to learn how to solve systems with three variables. Okay. You can use elimination and substitution methods to solve a system of three equations in three variables by working with equations in pairs. So you never even want to attempt trying to solve these by graphing. Okay, you're going to have the z-plane as well, and you're just not there yet. It's going to be very complicated. So you're always going to solve systems of three variable equations either by substitution or elimination. All right. You will use one of the equations twice, by the way. And when where 1 point represents the solution of a system of equations in three variables, write it as an ordered triple. X, Y, and Z. So please always remember that we go in alphabetical order. Okay? So that's how I'm going to write my solutions here. So, what do we do? How do we do it? Let's talk, guys. What is the solution of the system? And I've got 2x minus y plus z equals 4. And I've got x plus 3y minus z equals 11. And I've got 4x plus y minus z equals 14. Yes, sir. Let me teach it, sir, and I will tell you all of those things. Thank you for your eagerness, though. I do appreciate that. But let me teach. All right. So first of all, guys, number one, pair the equations of the system to eliminate one variable. Okay? Once you do that, now you have an equation with two variables. So what I do is I always take the first two. You want to take the first and the last one? You want to take the second two? I don't care. But I stay consistent. When I stay consistent, that means that no matter how complicated things get, I stay consistent. I do it the same way over and over. So what I did was I went ahead and grouped these two together right here. Now, from this point, now that I have two equations, I want to eliminate, get rid of, eliminate, gone, bye-bye, one equation. One variable. So remember, you could take the first two, or you could take the second two. I don't care. I'm not being sarcastic. I'm just clearly letting you know it doesn't matter. Okay? Who do you guys want to work with, red or blue? Okay, we'll work with red. Now that we're working with red, guys, now we got to eliminate. All right? So what I'm going to do here is I'm going to go ahead and eliminate. Who do you think we should eliminate from this first set? The z, for sure. So get rid of the z. What am I left with? 3x plus 2y equals 15. That's this guy right here. Does everyone see that? Promise. Okay, now, we've done my first two. That's done. Now I have to do my second two. That's why I always say pick the first two, because sometimes people will do the first and the last, or the bottom two, and they'll forget the first one. So take the first two as my suggestion, then take the last two, do the same thing there. But since you eliminated z here, who do you think you have to eliminate in the next one? Z. So what do you think we could do? I'm going to subtract the bottom by multiply the bottom by a negative. Give me negative 4x minus y plus z equals negative 14. The z's cancel. I'm left with negative 3x plus 2y equals negative 3, which is right here. I'm going to take a chill pill for a second. I'm going to let you digest what I did. I took the first two equations, which was the red, and I chose for myself one variable to cancel. We chose together that we were going to cancel the z's. So once we cancel the z's, we're left with a system with two variables. Then you take your next two equations, the second equation and the third, and you create a system there. Now here we have a little bit of a less choice. Here, the z has to be canceled. There's no choice. Whatever you choose in the first one, you have to get rid of in the second one. So that means this guy and this guy canceled, and I was left with that blue equation, which I put down here. Is everyone with me? Promise? Okay, now's the easy part. So write two new equations as a system, solve for the two variables. Now we're just solving like regular. We know how to solve this. It's in the setup for which? Substitution or elimination? Yeah, man. So I'll do this in green now. Bye-bye. 4y equals 12. Y equals 3. Now that y equals 3, how can I find x? Plug it in. Thank you, guys. So 3x plus 2 times 3 equals 15. Subtract the 6. 3x equals 9. Divide by 3. X equals 3. So now I have my x is 3. My y is 3. What's the last step? Plug in the known values into one of the original equations. Solve for the remaining variable. So x is 3 and y is 3. So I'm going to go back up here, and I'm going to plug it into one of these original guys. I don't care who to plug it into. What do you want to plug it into? I don't care. First one, okay. 3 times 2 is 6. Minus 3 plus z equals 4. 6 minus 3 is 3. Subtract the 3 to both sides. Z equals 1. So my solution, x, y, z. Moto, that's nice and all, but dude, there's a lot of work, and how do I know if I'm right or wrong? Plug it in. At the end, they've all have to be true. So 6 minus 3 plus 1. That's 7 minus 3 is 4. That works. 3 plus 9 minus 1. 12 minus 1 is 11. It works. 12 plus 3 minus 1. 15 minus 1 is 14. It works. That's it. That's the lesson. We're going to practice now, but that's it. That's the lesson, my brothers. Not bad, right? Yes, sir, my brother. Thank you. Okay, yes. Back to the question was, Mr. Morrow, when you started, you went ahead and did these two, and then you went ahead and did these two. The question, can I mix and match? Can I do this guy and this guy first, and then do this guy and this guy? Sure you can. I highly suggest against that. The reason I highly suggest against that is because I've seen in the past people use the same equation sometimes too many times or in the wrong order. So you can. There's nothing wrong mathematically. Me, I'm a creature of habit. So I'll 99% of the time take the first two and then the second two. Now, why the 99%? Sometimes the way they'll give it to you, the first two will have nothing that you can cancel out. So then by default, you're going to have to go to the first one and the third one. But when you have a variable in each one, again, it's just a suggestion. For me, the way my brain works, okay? The way my brain works, I'm going to take the first two and then the number 2 and number 3. But you're right. You can do it any order you want.
Yeah, I was just saying for the situation.
For sure. For sure, my brother. Thank you, sir. Yes, sir, my brother. Oh, absolutely. That's a great question. Look, that's where thought process is coming. I'm very proud of you. My boy said, wait a second, Morrow. But if you want to go ahead and take 1 and 3, okay? This will be 6x. The y's cancel, the z's cancel. So 6x equals 18, x equals 3. Super. No sarcasm. Super. And then what would you do from there? Okay, now, my brother, now you could take this 3, and couldn't you go, now this is 6 minus y plus z equals 4, and you've got 3 plus 3y minus z equals 11. Well, go ahead and subtract the 6. You got a negative y and a z. Subtract the 3. You got a 3y and a negative z. You cancel from there and you get the y. Once you have one, you can find the other ones. You with me here? Thank you, my brother. Any other questions before we continue? Thank you, gentlemen. Let's go. All right, what do we do here? What do we do here? What do we do here? I'm not going to tell you what I want to do. I want you to look. You tell me what you want to do. Looking at these three equations, which ones do you think you want to set up first? To be honest, I would have done the same thing, the first and the second. So I've got my x minus y plus z equals negative 1, and x plus y plus 3z equals negative 3. I'm not going to tell you what to do. Who do you guys want to eliminate? The y. I think that's smart, in my opinion. 2x plus 3z equals negative 4. That's my first equation now that I have with just two variables. Moto learn how to add. It is 4z because there's an invisible one. Yes, I know everyone that heard me sing there. They said, oh God, stick to math, please, Mr. Morrow. It's all right. I can make fun of myself. All right. You ready? Now that you picked those two, now what do you have to pick now? These two, right? So now I've got x plus y plus 3z equals negative 3. And I've got 2x minus y plus 2z equals 0. Who do you have to get rid of now? You have to. Good job. So this is 3x plus 5z equals negative 3. Now this is my second equation with just two variables. So now I've created a system with just two variables, right, my brother? So now I can take this red equation and this blue equation and set up a system now to solve for either the x or the z, and that depends on you, my brothers. So again, I don't want to tell you what to do. Now, who do you want to get rid of? And wait, before we get there, I know there's a lot of stuff going on, and you guys are working really hard. I can see it. Really proud of you. Does everyone see what I've done so far? In fact, I'm going to pause for a second. All right, my brothers, thank you for your honesty. So now, guys, who do you want to solve for? Who do you want to eliminate? X, okay. What do you want to multiply up here? Okay, someone said 3, so we'll do that. So that's positive 3. What does this have to be down here? Thank you, guys. So I've got 6x plus 12z equals negative 12. I've got negative 6x minus 10z equals 6. 2z equals negative 6. Z equals negative 3. Now that I have z is equal to negative 3, guys, I could plug it into either one of these, right? Hello? Yeah, so to find x. So now I got plus negative 15, because 5 times negative 3 is negative 3. So I got 3x equals 12. X equals 4. Talk to me? We're good? So x is 4. Z is negative 3. I don't want to jump up before you're ready. You ready? So now, x is 4. Z is negative 3. X is 4. Z is negative 3. Which one of these do you want to plug it into? I would plug it into the first one as well. Good job. Good choice, in my opinion. So I've got 4 minus y minus 3 equals negative 1. 4 minus 3 is 1. Subtract 1 to both sides, it's negative 2. Divided by negative 1, y equals 2. So my solution, 4, 3, 2. Let's prove it. Wait, 4. I'm wrong. Gotta go y and z in correct order. Thank you, sir. 2 and negative 3. Thank you, sir. So let's prove it. Let's prove it. Let's prove it. Let's prove it. See what we got here. I got 4 minus 2 minus 3. Negative 5 plus 4 is negative 1. It works. I got 4 plus 2, which is 6, minus 9, which is negative 3. And then I've got 8 minus 2 minus 6, which is 0. If one of them doesn't work, guys, then you messed up, my brothers. Questions, comments, concerns, problems, issues, dilemmas. All right. I'm proud of you guys. You promise? Let's do this. We're almost done. Okay, now. Okay. What is the solution of this system? Okay. What we were doing, guys, was the elimination method because we were eliminating. We were eliminating. Sometimes you can substitute to solve a system of 3 equations, or 3 variables, rather. Oh, no, 3 equations as well. This method is used when you can easily solve for one of the equations for a single variable. So, like always, this isn't always going to happen, but it's another tool to make it easier for you if and when it does happen. So in this particular case, guys, if you notice, you got 2x plus 3y minus 2z, then you got x plus a 5y, then you've got a 4z minus 5x. So I'm missing a z from this guy. I'm missing a y from this guy. So what on earth do I do? Choose an equation which can be solved easily for one variable. Solve for that variable in terms of the other. So of all the variables they give you here, which is the easiest variable to solve for? The x from the x plus 5y, right? So that's why I chose that. So now that I do that, let's solve for x. So when I go ahead and solve for x equals negative 5y plus 9. So far, so good? So I know what x equals. I've used the middle equation. Now I'm going to go ahead and take the other equations. I'm not going to say it's always going to be the top or the bottom one. I'm not going to say it's the first and the second one. I don't know which ones it's going to be. Sometimes it'll be the first, sometimes it'll be the second, sometimes it'll be the third that you can choose and substitute for. So the remaining equations, go ahead and make a system out of that for a second. Substitute the expression for the variable you solve for into the 2 remaining given equations. So I have 2x plus 3y minus 2z, and I got 4z minus 5x. So I've got 2 times x, which is negative 5y, plus 9, plus 3y minus 2z equals negative 1. So it's just negative 10y plus 18 plus 3y minus 2z equals negative 1. So I've got negative 7y minus 2z equals negative 19. Did everyone see where I made the substitution, why I made the substitution, and how I'm left now with only a y and a z? Thank you, son. Yes, sir, that's an equals, a very sloppy negative 1. I apologize. Yes, sir. And then you're going to do the same exact thing, guys, with this one. So I got 4z minus 5 times x, which is negative 5y, plus 9 equals 4. So I've got 4z plus 25y minus 45 equals 4. So I've got 25y, there it is, plus 4z equals 49. Thank you, my brother. I'm going to stop for a second. I'm going to hit pause and let you digest. All right, boys, let us continue. Now that I got these two guys, I've got a system of two equations with two variables. Now write the two new equations as a system and solve for both variables. Okay, so now it's easy. Who do you want to solve for? Z? I would do the same exact thing. What are you going to multiply this top by? By a 2. Yeah, by a 2. And then I'm going to go ahead and that's going to be negative 14y minus 4z equals negative 38. So 11y, thank you, good job, kid. Divided by 11, so y equals 1. Well, if y equals 1, how can I find z? Plug it in. You want to plug it into the top one? Cool. You can plug it into either one. So I've got negative 7 times y, which is 1, minus 2z equals negative 19. Add the 7. Negative 2z equals negative 12 divided by negative 2. Z equals 6. Now I got z. Now I got y. How do I find x, boys? Yeah, plug it both back in. Remember, all the way up here, we got the original equations. So what I would do, don't we know that x equals negative 5y plus 9? And doesn't y equal 1? So let's plug it in. X equals negative 5 plus 9, so x equals 4. Does that make sense? So then my solution here, you have my x of 4, y of 1, and then z of 6. No, don't take my word for it. Prove it. 2 times 4 is 8. 8 plus 3 is 11. And 11 minus 12 is negative 1. It works. 4 plus 5 is 9. Works. And then I've got 24 minus 20 is 4. It works. Does that make sense, guys? Golden? Not bad, right? A lot more intimidating than you thought. Good, good, good. I like your attitude, guys. Thank you so very much. Okay, what's the system here? You guys tell me what you want to do. You could do an elimination. You could do a substitution. I really will never make you do it one way or the other. And in fact, in real life, you're not going to be told either one way or the other. You're going to go the way that's easiest for you. Yes, sir. All right, let's do it. They're going to go a different route. Let's go their route. They're going to take 1 and 3. So I got x minus 2y plus z equals negative 4. Again, this is not the way I would do it, but who cares about me? I think this was actually quite brilliant. This was actually brilliant. My way would not have been as efficient as this way. So good job. Great recognition. Why is this so great? Check it out. 3x equals 6. So that's it. X equals 2 right off the bat. Okay, so now, though, we know what x is. I'm proud of you. What do you want to do now, though? Okay, well, yeah, but we need two more equations, though. Okay, so now they're going to take these two, but this time they're going to plug in the x. Brilliant. 2, good job, minus 2y plus z equals negative 4. Guys, notice how I write my z's? My z's and my 2's sometimes get confusing. Just do a little line through it, my suggestion. And then this is negative 4 times 2, so that's negative 8, plus y minus 2z equals 1. Who do y'all want to get rid of? Actually, let's rewrite it properly. Negative 2y plus z equals negative 6. and y minus 2z equals 9. Okay, who do y'all want to get rid of? The y? Someone said y. Okay, so let's multiply this by a 2. So you got 2y minus 4z equals 18. The negative 2y and the 2y cancel. Z minus 4z is negative 3z. Negative 6 plus 18 is 12. Divide by negative 3. Z equals negative 4. So z equals negative 4. X equals 2. How do we find y? Plug it in. And my boy said plug it into the top one. You got it. 2 minus 2y minus 4 equals negative 4. 2 minus 4 is negative 2. Add the 2, that's negative 2. Negative 2 divided by negative 2, y equals 1. So my solution in purple would be 2, 1, negative 4. Don't take my word for it. Let's prove it. Okay, 2 minus 2 is 0. 0 minus 4 is negative 4. It works. Negative 8 plus 1 is negative 7. Negative 7 plus 8 is 1. 4 plus 2 is 6. 6 minus a negative 4, that becomes plus 4. 6 plus 4 is 10. Works. Any questions at all, my brothers, before I do one word problem? I know, you're excited. We're good? All right. I'll take that as a yes. All right, guys. Now, you know I always got to throw in word problems, not because I don't like you, but on the other side of the coin, because I like you very much. And I want you to be prepared, okay? This is SAT kind of stuff. So let's just take our time. The sum of 3 digits of a 3-digit number is 12. Do we know anything about the digits, guys? So me, I'm going to go first digit. I'm going to call X. Second, right, digit, Y. Third digit, Z. Do we have to use X, Y, and Z? No, no, and no. But you got to label it with something, okay? So now I know that the sum of the 3 digits is 12, right? So isn't X plus Y plus Z equal to 12? Okay, next sentence. The tens digit, so remember in the sum of digits of a 3-digit number, where's the tens digit? First, thank you. So the tens digit, so that's my Y, is 2 less than the hundreds digit. Who's the hundreds digit? First, second, or third? So it's the third one, Z. So my second digit, which is Y, is 2 less than the hundreds digit. So we've got Z minus 2. And then, and the ones digit, which is X, no, which is Z. The ones digit, which is Z, is 4 less than the sum of the other 2 digits. So, yes. Remember, guys, 312. Okay? First digit, second digit, third digit. You, okay. This is the ones, tens, hundreds. Let me see. Well, hold on. The tens digit, which is Y, is less than the, okay, is 2 less than the hundreds, which you're right. That should be an X. Thanks, kid. Learn how to read, Moral. And then the last one, and the ones digit, which is Z, is 4 less than the sum of the other 2 digits. So we got X plus Y, and it's 4 less than that. That's the hard part. Once you're here, it's usually Mickey Mouse. What do you guys want to do? Do you want to substitute? Since you have a y already, I'm not telling you what to do. Do you want to do that? Yeah? Okay. So I would have as well, by the way. So I know that you have my y equals x minus 2. So I'm going to go x, which is x, plus y, which is x minus 2, plus z equals 12. X plus x is 2x. Add the 2 over. So 2x plus z equals 14. Okay. Now what? Can't I plug it into here as well? So let's do that. Z, love it when it does that. Okay, let's try that again. So z equals x plus y, which is x minus 2, minus 4. So z equals 2x minus 6. Guess what? I'm going to plug this z right into here. So I've got 2x plus 2x minus 6 equals 14. So now I have 4x equals 20. So x equals 5. And if x equals 5, what does y equal? Y equals 5 minus 2. So y equals 3. And then what does z equal? Well, z equals x, which is 5, plus y, which is 3, minus 4. So z equals 7. Don't worry, guys. You're not going to have 5 million of these on the test. You're not going to have 5 million of these on any SAT. You can have a couple, 2, 3. But the key here is the concept. Does the concept make sense? Yes, sir, my brother. Thank you. Thanks, brother. Yeah. You could have done this a lot of different ways. What my boy just finished saying was this. I didn't even see it. He said, Moro, doesn't z equal x plus y minus 4? Couldn't you have taken this and plugged it right into here as well? Yes, you could have. There were several different substitutions. We just went down one path, guys. Please don't look at this lesson later and go, okay, this is the only way that you can do it. Moro's direction was the only direction that you could do it. No. This is just one. That's why I let you guys choose on a few.
Yeah, but that's not correct.
Did we test it? Okay, hold on. What did we do here? I'm sorry? Oh, because I don't know how to add. 8 minus 4 is usually 4, not 7. Look at them apples. But guess what? How did you know I was wrong? Because you checked. What did I fail to do on this one example? Check. So that is a lesson in futility. Don't be like Moto and assume that it's done correctly. I did everything correctly. If I was grading my question here, I would have given myself partial, but I would have circled this and I would have put read. So please don't make the mistakes I make. Any other questions, guys? Thank you. God bless you. Hope you learned a lot. Have a great day. Bye-bye.